So you will start at 5 or letting until all participants in the room?
Yeah.
Okay. Okay, so we are live streaming right now. Okay. So I will make you a host, and then could you please add me a co-host and give me a permission to record it as well?
Yeah, of course.
Okay. Okay. So now you are a host. And yes. Okay. 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 That's it. Thank you. And you can start.
Yeah, you're welcome.
Yeah.
Should we wait for the other people or we just start right now? It seems that we only have 5 people. Maybe we can wait for 3 minutes so that, yeah.
Yeah, 3 to 5 minutes. Like just
Okay.
letting them. Okay.
Okay, good evening, everyone. It's already 6:05. So welcome to the evening tutorial, and it's also a question and answer session. So it seems that we only have this 7 people. So can we start now? I think you can feel free to post any questions about today's program or any other questions about the coding. You can share about it. I think maybe we can start from I will share my screen. I can show you a model that I trained this afternoon using the latest LSTM model. Actually, I think most of the people have already finished the homework yesterday. Maybe in yesterday's homework, you only need 10 minutes or 20 minutes to train a model, right? But actually, if you use the LSTM algorithm, so it's a little time consuming, right? So I just want to share a model I trained this afternoon using the LSTM one. So you can see it as a reference so that you can change your parameters more efficiently. Let's go to see the scores directly. My final score is 0.0006. It looks good, and the graph looks like here. So I just want to show some of my parameters. You can see I used two dense layer as here, two dense layer, and each layer have 256 nutrients. So after this two, I changed these two parameters. The first one is the batch size. I think I'm not sure if you have tried to change this size. So if you increase this number, it will speed up your computation. But if you decrease this number, you will have a more accurate model. You will have a better performance. So as Dan said before in this afternoon, the training model is a kind of the balance between the time and the performance, right? Actually, normally we do not need to spend a long time, maybe several hours to train a model. We maybe in our experiment, we just need to find a best way, maybe just in 10 minutes. So there's a lot of parameters you can try, you can change it, you can balance between the time and the performance. So this is the LSTM one. You can try to change these numbers from this group of numbers. And I want to show you a neutral network model I trained also this afternoon. So maybe this program I have to start from the beginning. Oh. There's some problem here. Okay. Okay, maybe let's go back to this one because it's a big about this one. So I will use this one. You can see I set 3 dense layer, and the first one is 256, and the middle one is the bigger one. Then also said we have we start from 16 dimension. Then I will extend it to the 256. So the third layer will be a large one that has 500, and I will slow down it to 200. So let's see its performance. So I will train it right now. Okay. Oh. Oh, okay. I will start this one. Okay, maybe I will from the start. Okay, it restart. It works very well. So in my model, it will take nearly 1 minute to run all the epoch. Actually, I received a homework from Amia this morning. So let's check his parameters here. So you can see his parameters like this. He used 1 layer, 2, 3, 4, nearly 5 layers. Actually, it's also the balance between the time and the performance. Let's see the result from my latest model. It looks like here. So if comparing these two set of parameters, you can see actually there's a huge difference. So my point is sometimes you do not need to use a lot of layers with a lot of nutritions to train your model. Maybe some people notice that with more epoch, the performance of your model will not increase if you set the epoch to a really large number. Speaking of this, maybe I want to show you a website that I really like it. It's called Playground TensorFlow organization. So I will copy this one to the Zoom so that you can experience it. Okay, I have to stop the sharing. Where is the talk? Okay, can you see it? Firstly, I will show you how it works and why I think that it's an interesting website. So as you can see, it's an online neural network model that you can train it much more directly than programming using the Jupyter Notebook. So just as we said before, there are several different layers in the neural network model. Okay, as you can see, normally we call this the features as the input layer. Okay, and the middle one is the hidden layer. That's the place where the program calculate a lot of things. So the third layer is the output layer. So let's see how it can work much more directly. So the problem we want to fix is that, for example, we have a group of points with two different colors, right? One group of points is orange and the other one is blue. So we want to find a method to figure out how we can divide these points into two groups. So in this method, we will use this neural network algorithm to figure it out. The reason why I like it is that you can add different layer from these icons, and it's much more directly it's really obvious and it's easy to understand. So for example, if I set 2 hidden layers and each layer we have 4 nutritions. Let's see how it works. I can I can uh, I can click the play button, and here you can see that this is the epoch. So the most amazing part for this website is all the computation is online. So it will not so as you can see, the calculation process is really fast, right? So you can check the result. It can help you to save a lot of time, and you can see the graph at here. Actually, it's a quite simple question. So I will try to reduce the hidden layer. So let's try to find an easiest way to make it. So if we only have 2 hidden layer and each layer have 4 nutrients. So let's see. Okay, it will need maybe 70 epoch to find this result, and the test loss will, yeah, it looks good. But what if I reduce 1 hidden layer and reduce 2 nutrients? Let's see the result. So okay, as you can see, finally it cannot find a method to divide the points into 2 groups, right? And the test loss will not change if I keep going it, right? So there are 2 people just join in the WeChat, so I will share them with this website again. Hi, Bo and Darcy. Can you try? It's an interesting website that I'm showing. You can try it in. You can try it.
Yeah, cheers, mate. It looks really good. Thank you.
Yeah. So we will keep trying it. So it's obvious that with only 1 hidden layer and 2 nutrients cannot fix this problem. So I will try to add some more. Let's see whether it works. Yeah, it's okay. So you can see, maybe I will restart it. You can see near the 70 epoch, the program will find a result to solve this problem. So this is the most simplest one, and we can try to add some difficulty. So in this kind of situation, we can run it directly, see how it works. Yeah, it's okay. But the difference between 1 hidden layer and much more hidden layer, actually the difference is the speed. Normally we do not have a super fast computer, right? We only need to have to use some cloud computation to have a better result. But actually, so much hidden layer is necessary in most of the conditions. So that's we can try to add some more features as the input, so it can solve the problem with a better result. Yeah, as you can see, it's like here. Actually, there are 4 groups of data. You can train it online, and you can enjoy this high speed of the computation. You can there's a lot of things you can change, such as the activation, the regularization, and the problem type. So during this process, you can experience the changing of the parameters. Maybe it can help you to save a lot of time. Okay, that's this website. Let's see. This is a neural network model that I trained this afternoon. Let's check the final result. Okay, maybe I do not need this one. although this score looks not so good, but actually, as I showed in this website, it's a kind of balance between the time and the final performance. Normally, there is no too much obvious difference between this one, between the 0.001 and the, for example, 0.0006. I think normally in our experiment, there's no big difference between this kind of two models. The only difference is that if you want to have this kind of result, maybe you need to train the model for half an hour. But as you can see, for this result, I only used 3 minutes. Yeah. So I think you can keep enjoying how to change this kind of parameters. So what I want to say is just this. So do you have some problems about today's coding? We can talk together, and if you want to share your screen, you can share it now. So
I had one error message. I think I'm pretty sure I know which step I missed, but I just don't know where it goes. So
okay.
Let me share my screen. So this is my error message here. The name error, because I didn't know there was one point where we had to define the optimizers and I couldn't figure out when that was, and then class was over. So
okay, you need to type this one at the first line of this block. So actually,
okay.
it's a really easy question. It
so
shows
here?
that you, at here. You can try it. So the error log shows that you do not have an optimizer. You just need to import it. Yeah, it's okay.
Thank you. Yeah, I knew it was super simple, but I just didn't know where.
Yeah.
Thank you.
It's quite common.
We just went through them so fast that I was lost.
Okay. Any problem?
I just got a quick question. I had to go to work today and teach a class, so I had to drop in and out. It was the first day back on online learning, and it was very interesting, to say the least. Will today's stream be uploaded anytime soon?
Today's tutorial is about some more advanced neural network, such as the recurrent neural network and the long-short LSTM model. It will have a much more accurate result, but it will.
Cool. My question is though, will the session, the recorded session, be uploaded onto YouTube anytime soon?
Oh, sorry, I'm not quite sure. You have to ask the Cadre team.
Yeah, no worries. Cool. No worries. Thanks, Heaps. Just I've followed along pretty well, but I'll catch up probably tomorrow morning.
Yeah.
Thanks, mate. Cheers.
Yeah. Or maybe if someone wants to show the model that you trained before, we can check it together.
Okay. Yes, Gongxi. I think my my coding is pretty messed up. I will share my screen.
Yeah, of course. Okay, just a little lower, please. Maybe the bottom sentence in the arrow. Yeah. Okay, I think you are missing one sentence that we add to the program today. You need to this one. And I copied it to the chat box. Can you copy it in your model? Oh, I noticed that you already have this one. You just need to delete the hashtag. Yeah, delete the hashtag.
Okay, is that right? Let me run it again.
Yeah.
Cool. Yep.
Yeah, it's only because the shape of the data set is different with the neural network, so you have to enable this sentence. Yeah.
Okay. Well, one quick question. What is about this one? What it means? The present.
Oh, okay. It will calculate the time that you're
processing.
It will the processing time. Yeah.
Cool. Okay. Thank you.
Yeah, you are welcome. Okay. Speaking of the time, as you can see, I add a little, just one word, at the top of the block. So the final result will add one. That is the wall time. It means that my block used 3 minutes for the calculation. So I will also share it with yours. This one. You can try it in your program.
You put that in the calculation in exactly at the end of the X reshape. You paste the time at the end of the X reshape in the calculation.
Any questions? Or if someone want to train your model online so that we can see the process of your training, we can train your model together.
Yeah, I have some question about the coding. When you show your program, I think there's some difference between us. So can I share my screen?
Yeah, of course.
Yeah. Can I see my screen?
Yeah, it's okay.
Yeah. So it's a little bit different between us here. Yeah, I don't know. Is there any mistake in mine or?
Yeah, I think it's almost same. There's no errors. So can you run it or?
Yeah, I can run that here.
Okay, it looks like you have a powerful computer. The speed is really fast.
Oh, which parameter that I can play for today? Because there's so many parameters.
Oh, okay. You can change the dropout. Can you see that? The dropout there is the 0.2. You can change it to the 0.5. Actually, for my part, I don't think the dropout is useful in our experiment. Maybe you can just delete it directly. So I think the most important parameters are the dimension of the dense layer. You can try to add some more dense layer, such as you can try to set 4 dense layer with different dimensions.
So I can still play with here.
No, actually, you only need to change is the bottom one, the bottom 3 sentence.
This, yes.
Yeah, you can change the dimension. You can see there is 64. You can try to change it to 128 or the 256. You can change it. So you can see there are only 3 dense layers, right? You can copy one sentence again. You can try to increase the layer of the dense layer.
Yeah, like copy this.
Yeah.
Okay. Okay, I will try later when this finished.
Mm-hmm.
Okay, thank you.
Mm-hmm. Okay.
Hi. I have a
Hi. Mm-hmm.
more general questions
Mm-hmm.
in the training model. May I share my screen?
Yeah. Yeah, of course.
Let's see. So earlier, I'm trying to understand what I have in here. So this recurring model, the input here is a 2-dimension, right?
Mm-hmm.
And
Right.
then the
Yeah,
unit
that's right.
is 128.
Mm-hmm.
My question is, I thought when we input it, we have 80 input and 80 output. So why is the input dimension here is only 2?
Yeah, that's a good question. I think the dimension means here is a 2-dimension array. It's not the 2-dimension of the data set. So I'm not sure I can draw some this one. Can you see that?
Yeah, I can see the green. Yeah.
Okay. Normally, this 2-dimension means that you have a 2-dimension array. It's like this.
Mm-hmm.
Yeah, it's a 2-dimension, right? So what's the 1-dimension? We often call it is a list, right?
Right.
So this is the list. This is the 2-dimension. So the dimension have 2 different meaning actually in the machine learning algorithm. You said there's a 80 dimension. That means you have a 2-dimension array that the feature have 80. You have 80 feature. So in the machine learning, we can call it 80 dimension array. This is a little complicated. Can you get it?
Can you repeat
Oh,
that?
okay. I will try to draw it again. Yeah.
Sorry.
So in our experiment, we have a lot of data, right? Where's the most? Yeah. I will try to draw it more accurate. So it's a two-dimensional array, right? For instance, we have different samples, and this is the sample 1, and this is the sample 0, and this is the sample 1, sample 2, and this is the sample n, right? And in each of the sample, we have different features of this sample. So it's recorded in this line. So this is the feature 1, we call it the F1, and then the F2, so F3. So the last one will be the Fn, right? So the 80 number is this one. That means for one sample, we only have the 80 features in a line. 80 features. Can you get it?
Okay.
Yeah. So the 80 features in the machine learning, we often call it the 80 dimension. That means one sample have 80 features. We also call it a dimension.
Okay.
Yeah.
So in this case, the two-dimensional array, the two dimension is referring to the X and the Y, right? It's not referring to the dimension that you are drawing or the feature that you're drawing.
Yeah, you
okay,
can
that makes sense. So it doesn't matter if I change that to dimension because we only still have 2, so it won't impact any of the result.
Yeah, that's right. Because our data set is only a two-dimensional data set, we are not calculate something like an image that maybe have different layers that have the red color, green color, or the blue color. That may be the 3-dimension.
Okay, that makes sense. And the I understand that changing the units of the recurrent model will increase the performance, but I maybe then the explain it in the presentation, but maybe I got lost. What is the units in this particular case? Is yeah.
What do you mean the unit?
So before that, the unit was only 16s, right? And then obviously it give us a lower performance in the training. But now I have bumped it up to 128. So it's significantly improved the performance. So does when I bump up this particular units in the network, is it just initial input from 16 bump up to 128? Oh, okay. Oh, that makes sense. Okay, cool, cool. That makes sense.
I'm not sure if you remember we talked this afternoon or in the morning. So I remember that there's one people, they in his model, the first layer they set it to 16. So so actually in the input layer, input is here. So in the input layer, we have maybe 100. So from the 100 to the 16, in this process, a lot of data will be missing. So so if you set it to a small number, that will be not good. Normally, we'll set it will a little large than this number, maybe 128 and 256, something like that. You can enlarge this number at first, maybe enlarge it again to 500, and I will reduce this number in the third layer to this one, and this will be the final result. This process will be better.
I see. Okay, that makes a lot of sense. Yeah, that makes a lot of sense. Thank you so much for explaining
you're welcome.
that.
Guangxi?
Hi. Okay, do you have another question? It's also the arrow about the shape of the data set. So I'm not quite sure. It looks right because you have already added this one. So you have a final result. Well, I'm not quite sure about it. You have already trained your model and you have the score of the model, but in the graph process, it has some. Maybe can you just enable this sentence? Sorry, disable this sentence.
This one, right?
Can you have a try? Yeah, that's right. Can you have a try?
Yes, it's still.
It's still arrow.
Yeah.
Oh.
It doesn't recognize this test X. Is it possible that I mistyped this X test into test X?
I don't think you need to change the code. Maybe the arrow becomes in the upper box. Can I just can I control your computer? I'm asking for it.
Sure.
I will check the upper one. Okay, from here. Well, I think there's no error in your program. So can you just run these blocks one by one again? Okay. Maybe you missed the one of the block.
Okay, I'll try it.
Yeah, it looks good. Yeah. So there's one thing I want to share with you. I changed the code a little bit, as you can see in the yesterday's. So yeah, can you see the screen now? Okay. In the yesterday's model, we use this one, right? So after running this code, we can have some data like this in the model. Yeah, it's a kind of the performance of your model. You can check in the notebook, right? But I just slightly changed the name of the model so that if you are training an LSTM model, the name will have a difference. It's a difference between the yesterday's model. It's quite easy. I just copy this one and paste it again. So I change the NN to the LSTM. So that's it. Okay.
Excuse me. What did you change?
Oh, I will share the screen. Okay.
Thank you.
Actually, in the yesterday's program, it looks like this, right? I will save my model in a folder named the model, and it will start from the N and N, right? So the files we saved in the folder will be NN and 1 and several numbers, right? So because today's homework is about the training of the LSTM, so I will slightly change this one. I just copy these 3 sentences and I paste it again, and then I disable these 3 sentences. Okay, I just change this NN to the LSTM. Okay. So in this situation, I just delete these things. I run this block again. As you can see, the new tech notebook will start from LSTM. Yeah, it's quite easy.
Yeah, thank you.
Yeah, it's okay. Okay, any questions?
In my case, my
go
model
ahead. Thomas, go ahead. My question is related to the playground TensorFlow.
Mm-hmm.
Oh, thank you, Washington. No, I was saying that my model is being super slow, the approach.
Mm-hmm. Yeah.
And I don't know if it's because of my computer,
Mm-hmm.
but I will share my screen. I think this one. See, it has been taking like at least 10 minutes. So
okay, yeah.
But I also I hidden another dense layer.
Mm-hmm.
So I already have one dense layer. So how can I like increase time maybe, or decrease the amount of time invested in the?
Okay, I got it. Actually, if you are using the LSTM model, it's really a little bit time consuming because the calculation increased a lot of. So the only thing you can speed up is you can increase the number of the batch size. Can you find it? Increase the batch size. Yeah.
The batch is here. No.
Batch size in the model feed. Can you find it? Sorry, not in this block.
Yeah, I know.
Yeah, the batch size. If you change this, if you increase this number, you will speed up your calculation speed, but the accuracy will slow down. It's also kind of balance. You can have a try. Yeah. For example, you can try to change it to the 128. You can see there's.
What is exactly doing the batch size?
The batch size means in each epoch, how many samples will be calculated.
Okay.
Yeah, in short, this size is not as bigger as better. So if you set this batch size to maybe 8 or 4, you will have a really good performance, but it will take a really long time to calculate. I remember that I have seen some paper. So in some professional, in the professional computer science area, they sometimes will change this number to 1 or 2. It needs a huge computation. So actually for our experiments, the 16 or 32 is enough.
Okay. But sorry, like in professional computation, you said that this number goes up to 100?
So sorry, 1 or 2. 1 or 2.
1 or 2. So
yeah,
if it's lower, yeah, I mean like batch size, it's kind of the resolution of the amount of samples, like you are reducing the size.
Yeah,
it's
yeah,
when you
a little bit like that.
No?
Yeah,
it's like when you do a render and you reduce the let's say the size.
Yeah, it's a little like that.
Right.
Yeah,
Okay.
it's true. The resolution.
Yeah. Okay.
Yeah, you can change it to the 128. You can see the speed will boost.
Yeah. Okay. I will finish this
you
one.
Can have a try.
Thank you.
Yeah.
Thank you.
You're welcome.
I have finished the program running and got the result. Can I share it?
Yeah, of course, please.
So there are like 2 results here. So I don't know which one can I choose as yesterday, because yesterday.
I think the first one is the score. I forgot what's the meaning of the second one. So it looks like I just checked from the graph. It looks like your model is good, I think.
So this is the score. And I can change like copy more layer, copy more this line to get the small score of this. Yeah. Oh no, to test.
Also, sorry, maybe there's a mistake. Can I control your computer? I'm asking for it. Yeah, I noticed that there was a big problem. You can see the accuracy is 0.01. Oh, it's pretty slow. The thing is, I noticed that you just set 64 as the nutrients of each layer. I think the 64 is a little bit small. Can you try to increase this number? I think you will have a better result.
Oh, okay.
Mm-hmm.
Like to
100 or 200, or maybe you can try maybe 500 in the second layer.
like this.
Yeah, it's okay. You can have a try. Because I see the value lost is a little big, so that means the model may be not so accurate. So I just want to you can try to enlarge add more nutrients.
Okay. So after the program running, so is there something related with this picture, or do I need to change like here as yesterday?
Yeah.
Oh, okay.
I think there's no problem in your code. You can have the screenshot like yesterday.
Okay, so it's also I can play with these two parameters to get the different.
Yeah, of course, to check different curves.
Okay, I will run the new one. Thank you.
Hi, Portion. Do you want to share your experience about the playground?
Yeah, I just have a quick question. This.
Yeah, actually, I haven't played this for a long time. I nearly forgot it. Yeah, can you share it?
Yes, give me 1 second. Okay, my question is related to the input of the playground. So we just kind of talk about the features or the input dimension is 80s, right? So does that mean somehow I need to change the features right here to 80s? And when it comes to the second layers, well, in this case, to 80s, and then when it comes to the second layers, I need to add to 512 dimensions input. So I need to add here, or either I need to do 80 here. Is that correct, or 80 in the features?
You can yeah, it's a kind of like that. There's 80 input as the features we extract from our experiment, from the pictures, from the video. There's almost 80. I'm a little forgot it. So we have 80 features. Then so the second layer, the first hidden layer will be a little bit larger than the input layer.
Right. So is there a way for me to add the input here, like to 80? Because right now it looks like I only have 2, right?
Oh, that's impossible because it's only a demo website. That means you can only have these functions showed in this website. I remember that the number of the nutrients is limited and the number of the layers is also limited. Maybe you only can create 6 layers, maybe, yeah.
Okay,
it's
so I can,
yeah.
Right, yeah, okay, so I can just kind of do the equivalent number from to here and simulate the outcome. Okay, got it. Thank you so much.
Also, you can try to change the batch size. Can you see it at the left side? The batch size. And the test data, there's a lot of things you can change it. You can play with it. So it's called playground.
Okay. Gotcha. Yeah.
Yeah,
I
the
see it.
backside. Yeah. That's right.
Like this is what we were using. Yeah, I got it. Okay, cool.
Yeah, and there are 4 data sets. You can change you can try the hardest one, and that is that this one.
The spiral.
Yeah.
Cool.
So the machine learning is try to find a way to divide the points into 2 groups. You can try to find out good ways to make it.
Yeah. I will definitely give a shot. Thank you so much.
Yeah, it's okay. So any questions?
So the training model that we have done, the file is that .h5 file. Is that correct?
Yeah, it's correct. H5,
okay.
Yeah.
So maybe we will talk about this tomorrow. Is there a way to say that we already done the trainings and we thought it was a good performance? Can we improve that particular model? Like, are we able to okay.
Yeah, of course. Actually, the reason why we save this model, that is we can reuse it again. We do not need to train every time when we use it. I think there's no code in the program. Maybe we can share it tomorrow. So we will tell you how to read the model we have already trained well.
Yeah, that would be really great to see how we can reuse this particular
of
model.
Course.
Thank you.
So any questions? No problem. So maybe I will wait for 5 more minutes. If we are all, if all people have no questions, we will finish today's tutorial, maybe.
What will be a good platform that you would suggest for us to continue to learn TensorFlow?
Yeah.
Do you have a good platforms that you use as a resources or library?
Oh, yeah, okay, that's a good question. So I will share my screen. I think the workshop is on the 3 days workshop. Actually, there's a lot of concepts about the machine learning. I think the best way is you need to find a book. So there's a book I suggest that it's named the Python Keras. So sorry, I forgot the whole name. Maybe the Python Keras Deep Learning. This one. I will show you the first page of the book. Not this one. Maybe Python Deep Learning. Oh, this one. You need to remember the first page of this book. This book was finished by someone. Sorry, I forgot the name. Actually, it was the author of this book is the person who created the Keras. So in this book, he described all the concepts, all the words in the TensorFlow, but also and also in the Keras. So it's a kind of dictionary. You can check all the words in this book. I remember that there's also a lot of examples he posted in this book. You can try to follow it step by step. I think this is the best book. I think if you want to learn the machine learning from the start, from the beginning. I think this is the best one.
Excellent. Thank you so much.
Yeah, it's okay. So if you do not have some new questions, I think it's time to say goodbye for today's work tutorial. Is that okay?
Yes.
Yeah, thank you so much.
Yeah, you're welcome.
Thank you very much.
So see you tomorrow. Goodbye.
Thank you. See you tomorrow.
Bye.
Yeah, bye.
Thank you. See you tomorrow.